Hey everyone, how's it going? Welcome back to the final part of this hands-on with Maxon Redshift workshop. My name's Ellie and I'm joined for the last time, only of this workshop, with my good friend Chad. How's it going, Chad?
Well, I'm devastated and heartbroken, but how are you?
I'm devastated and heartbroken as well. I can't believe we're on the final week. Like I know I say this every single week, that it just kind of like flies by, but these sessions are just gone, and I'm gutted we're at the last one, but I'm also like really excited to get into all of the cool stuff that we're going to be doing today.
Yeah,
And
we have two
hey to
hours of
everyone,
goodness ahead of us. So, like,
we do have 2 hours, yeah, which still goes too quickly, but I'm going to be keeping an eye on the time, so we'll be getting to lots of good stuff. And hey to everyone in the chat as well, to Bernd, Sharon, Enno, Francesco, Hannah, Philip, Ryan, Jay, Anders. It's so nice to see you guys here, and some familiar names that we've been getting used to over the last few sessions. So yeah, thanks for being here, everyone. It's a pleasure as always to see you here with us. So let me start my little presentation for the final time. And my plan is I'm just going to sort of like speed through this because, you know, we have so much cool stuff to get through over the next 2 hours. I don't want to waste it talking about all this stuff. So really quickly, the overview. So if you did want to catch up on any of the previous sessions, you can do on our Maxon Training Team YouTube channel. You know, we split this into 4 different parts. And today we're sort of, the title is slightly misleading. We're going to create a Cyberpunk render. So we are going to be taking a look at the empty scene file of that render. But as you can imagine, we can't create a whole render in 2 hours. But we're going to look at the process that I would sort of go through, and a starting point, as well as some other little like bits that we haven't actually got to over this whole workshop. So again, these are the extra bits. You know, all our sessions are recorded. They're on the Maxon Training Team YouTube channel. Everyone, I believe, should now have had their trial for Redshift extended. We sort of made sure yesterday and today we did those final ones. So everyone should be able to follow along. But if not, you know, you can drop us an email at training@maxon.net and we can do that for you. Again, unlimited access to everything, including the Kitbash NeoCity kit, which is what we're kind of going to be working with today, including all of their materials. And, you know, if you need this information, I'm pretty sure Chad won't mind sending you the links for that in either the chat or inside of the questions, because I think we've kind of realized that not everyone has access to the chat, which is, we don't know why. So drop us a question if you need any of those links and we can absolutely send those to you. That is not a problem. So what are we going to be doing today? So part 4, final part, which we're all very, very sad about. So the plan is we're going to be looking at this Cyberpunk render and the process to how we would go about building this up. And so a lot of this is going to take the knowledge and the information that we've learned over these last few weeks, but we're going to be diving into looking at creating some of our Kitbash textures. So if you work with like Kitbash or Unreal or like Substance, and you have all those like lovely PBR texture maps, we're going to be looking at building those in a physical way. And we did kind of look at this when we looked back at node materials, but Kitbash textures in particular and Substance textures come with some extra texture maps, which we haven't actually looked at. So we're going to look at how we can kind of use those, like a metallic map, which is like our metalness. We also have like opacity maps and emission maps. So we're going to be sort of messing with some of that stuff as well. And then we had a couple of questions last week about the asphalt road with all those sort of like puddles and textures on, and we're actually going to build that from scratch today as well, and that's going to use the puddle maps inside the project files. I do also want to take a quick look at post effects because we ran out of time last week. There was too much stuff to go through, and so we'll have a quick look at how we can just have a look at post effects and what exactly they do, and then you guys can, you know, mess with them in your own time. And then probably the big topic today is going to be diving into some of the advanced tab render settings in particular sampling, globals, global illumination, and then also we're going to look at AOVs. So what they are, basically they're like multi-passes, they're render passes, and we're going to look at how we can set those up. So don't forget, we do have a questions area, and Chad is here with us to be able to ask your questions and chat to me. And it's been so great having you here, Chad. It really wouldn't be the same without you. And so
Thanks, Elly. Glad to be here. Sorry that I can't answer all the questions.
Oh no, don't worry. So will we have, oh, that's a good little segue to talk about the fact that we now have week 3's Q&A on the Dropbox. So you guys have been asking, for anyone who is new-ish here, you guys have been asking so many amazing questions over like this whole workshop that we've actually been going in and writing all of them down and just dropping some of the answers in there for you guys. And so week 3 is now on there as well. And anything that you guys asked this week, I'll make sure is on there, maybe by Monday, maybe.
Also, I put a link to that page that has the link to the Dropbox and the project files, or the link to the Dropbox, the project files, and the Q&A. I put that in the chat and also in the questions too. So should be
perfect.
there.
Perfect, thanks, Chad. I've just seen from Thomas that he was saying in the handouts it's only Q&A for week 1. Yep. So the rest of the Q&A is actually on the project files link that Chad has just sent. So yeah, we've got 1, 2, and 3, and our little course guide as well in there. So let's get into what we're going to be doing. So I'm actually just going to switch my camera off so you guys get like a nice full screen view, but I will be back before the end, so don't worry. And I missed the button. There we go. Right, cool. So let's get into what we're going to be doing. Let me just move that out of the way. Okay, so this is the final scene file that we're sort of going to be working towards, and you know, we're not going to be able to create this whole thing today. Like, we cannot create this in 2 hours, not with all the other like great stuff that we want to go through, but we can talk about the process that I went about to creating this actual render. And so let me open up my Redshift render view. And so you guys have access to this project file, and you can take it, mess with it, do whatever you want with it. It is absolutely yours for the taking. And let me just kick off this render view. It's going to take a little bit longer to just sort of like process those textures the first time around, but then eventually it should, she says, it should kick in. Here we go. So we have this shot here, and this was taken from the Kitbash NeoCity kit. So we have these really cool looking like buildings, and actually, so this little bus stop thing here and some of the other little bits were taken from the asset browser. So I kind of tried to separate these as much as I can so you guys can see the different things. And we've got our volumetric lighting. So, you know, we went through that in week 3. And then we have a series of area lights and a dome light. And we also have, hopefully you guys can see, we have area lights connected all around our scene as well. So you're probably thinking, hey, those 3 lights are doing a lot. No, we actually have a whole bunch of, well, if I can find them, here we go, area lights inside this shot as well for each of these things. And the reason we do this is, 1, to get some nice overall lighting in our shot, and it's also to help create this look of volumetric lighting. So we get these nice sort of like light beams coming down, and we get some nice reflections as well. So the plan is basically just to sort of look at maybe setting up some lighting for this, and then we're going to convert a couple of our textures, and then we're going to create this asphalt floor. And that's then going to give us the knowledge and the information to basically then do the rest of the scene in our own time if we want to. So if I just come over to my Cyberpunk empty scene, and as we can see here, it's literally just the geometry. But what I've done is, so when I first downloaded this kit from Kitbash, it was for Cinema 4D and it was for native Cinema 4D. So all my textures came in as native C4D textures. And so what I then did was I created a Redshift version of each one. And the reason that I do that is because if we have a look, so if we sort of like come over here, you can see on this like particular building, we have loads of different materials that are all connected to the different polygon selection tags. And so I like to keep these on here, and so I can easily replace these textures without having to, you know, reassign it and reset up the selection tag. And so we're going to have a look at how we can do that and how we can actually quickly reassign materials. But if you're wondering why, like, Ellie, why have you left just like a load of like black textures in this empty folder? Well, it's so when you then create them, you can just sort of like reassign them. And these are also now Redshift ones as well, just to make it easier for everyone else. So we'll come back to sort of that conversation in a little bit. Let me just kick this off, and we're not going to be able to see anything because we've not really got anything going on in here. And so if I was, so let's say I'm starting from scratch, but I've built this scene, I've got my geometry, and I'm now ready to go, okay, right, I'm ready to put some lighting in and start building some materials, and then eventually get to my render settings. Because all of these textures are pure black at the moment, even if I add a light in, and so that's what I would do, I would normally come up to my Redshift menu and I would add a dome light. So as we can see here, we're not really getting a great visual representation because of all of these black textures. And so in this case, I might just change my, let me just pull this over so we can see it a bit better. I would just change my sort of like render view here from regular to clay. And this is just going to give me a nice clay render to see how my lighting is starting to light my geometry before I've even set up any of my materials. And the HDR that I used, let me try and find this, was
so Elly,
this. Yeah.
Just really quick, is that, so what that does, the clay, that basically, that removes all materials temporarily for the view and just replaces it with the like matte or a Nair blend looking thing there? Is that what that's doing?
Yeah.
Okay.
Yeah, pretty much. It's just this sort of like plain diffuse gray material. And it's like the only reason that I'm doing this is because I have all of these like pure black diffuse textures.
Right.
And so it's not giving me like a good, I can't really see anything even though I've added my dome light. So that's the only reason I'm using that clay. It's just so I can see how this is set up. But if you'd built this geometry like normally, you wouldn't necessarily have all of these black textures. It depends on like the way that you bring the models in.
But it seems like it could be really helpful too, like if you had a bunch of like displacement or like, because sometimes, you know, like with Redshift, you could affect more than just kind of like a basic material stuff. You could displace stuff, you could, you know, have the volumetric stuff with the fog. And so it seems like it could be helpful if you could just instantly change everything to clay for a second.
Yeah, it's definitely, and there's also like a material override option, which we'll look at when we look at like render settings later, which can be another way of doing like a rendered version of this without having to like worry about like disabling all of your textures, which could be a lot of work.
Love that. Awesome. Thank you.
No worries. So let me just throw in this HDR, which is in this texture folder. So when I was building this scene, I deliberately chose a HDR that was going to match the type of lighting and the type of aesthetic that I'm going for. And so let's say this is a bit of like some like, I don't know, cyberpunk city where you've got those neon lights and you've got all that like cool like pink or blue like glow going on. Because that's the aesthetic that I'm going for and that's the style that I wanted to make sure, or I want to make sure when I'm creating my lighting that I match that kind of style. And so for me, this HDR works absolutely perfectly. And if I just drag that into my texture area, no, I don't want a puff. We now it's a little bit confusing to see that. So I'm actually just going to switch off my background. I don't want to see that. And so now it's almost looking like, one, it's looking more of like a nighttime scene, and it's also looking like we're getting these neon lights coming from, as if there were buildings coming from beyond the camera or behind the camera. And so I might even up my intensity just to sort of like pull this up a little bit. And so this would be like my starting point. I would always start with a dome light and a HDRI, and that's exactly what I did on the final render here. And then my next thing, so if we're talking about like imagining what the rest of this shot looks like, and so let's say behind the camera, so we have our road here and we have our curb, and so what we would have would be other buildings around here potentially that we haven't made, that we don't have to make because they're not in shot, but we would get some light from those areas as well. And so for me, I'd actually then throw in some area lights to give the impression that there are other buildings and other neon signs in these sort of areas around here. And we can just really, really easily kind of not fake it, but we can give that impression by grabbing ourselves like an area light. Maybe sort of, can we go to my default? Oh, I haven't set up a camera yet. Oh, never mind. Let me just come into here. What I'm going to do, let me just throw in a Redshift camera. And my reason for that is so I can work on this. I want to work on this view, but I want to be able to see my render view update. So I literally just threw in that camera, and so now I can work in here and see what this is doing. So what I've done is I've just thrown in like an area light. I've not actually changed any of the settings yet, and I may not, depending on how it looks. And it's giving an impression that there are buildings or other lights or other like neon signs or whatever coming from outside of my shot. And that would be in the real world. Like if I'd built this entire city up, we would have those lights coming in, but we can kind of fake it this way quite easily. And I'm going to do the same thing. So I'm just going to duplicate my area light, and I'm just going to rotate that 90 degrees and then maybe like pull it back a little, just to add some secondary lighting. And because we're talking about Cyberpunk and we're talking about like a neon city, I'm going to change the color of these lights. And this is what I did. So my light that's here, I'm just going to make it, you know, this sort of like cool pink color. And then my second area light, so this one that's going to be here, we are going to make it, let's find like a nice blue. I'm going to do like this blue color. And so already we've taken that with just those two area lights, we've taken it from this, which is our dome light and our HDR, to this. And I like this feel. I like the kind of the style that this is going in. You know, we like that bright pink, we like that bright blue. And when we start to add our emission and our other textures, this is going to add to our overall aesthetic. And so this was how I lit that final Cyberpunk City full render. So this one here, it's literally, as we can see here, we've got our two area lights and we have our dome light. The only other thing I did was I added area lights to each different section inside of here. And so we can see in here, we have area lights. If I come out of my camera, hopefully you guys can see, we have these connected to each light source. And so this can be a slightly time-consuming process because, you know, you're having to sort out the sizing, sort out the positioning. You could make them a child of the particular object and then zero out your coordinates to get them closer. but the effect that you get from them, and if you set up volumetric lighting and things like that, is definitely worth the time that it takes. So I would recommend that. So we're not actually going to do that because, you know, that would just take a lot of our time, but that is the lighting setup that I did for this final shot. And so, you know, it's a really simple setup, but I think it's quite nice and it's very effective. So the next step, now we've set up our lighting, and let's pretend we've set up all of our other area lights as well, would be to start to convert these Kitbash textures or the textures that we have in our scene, whether it's, you know, native C4D ones or any other software. And the way that we'd go about that is, if I grab my textures file, so we're going to build a couple of these textures together because it's the same sort of process. We're going to build the still raw, and then we're going to build this screens, because you can see we have a bunch of different maps for screens as well. So what I'm going to do, I could build these directly inside of these, because I've already set these up as Redshift materials. But let's pretend that they're native Cinema 4D textures, because if you're downloading a model that's set up for native C4D, if you're downloading something from Kitbash or you're pulling something in from Substance, you're going to want to create the Redshift material, and then there's a way that you can then replace the native texture. And so I want to show you that texture. And so if you're wondering why I'm not just building it straight in the shader graph, that's why. So what do we do? So we're pretending this is our native C4D texture. I would come up to my create menu, and I'm going to create a standard Redshift material. And then we're just going to call it new. And I like to keep things like generally the same names, just so I know what's what. So this is my still raw. This is my new still raw. So I'm going to pull that in here. What I'm going to do, I'm going to kick this render view off. I'm going to come back into my regular view. And if we look at still raw for a sec and look at its assigned tab, we can see all of these different objects that it's assigned to. And so I don't want to have to, you know, like you can right click and select object, and it takes you to the object. And then we can see, oh, look, it's on here. I don't want to have to, you know, find this texture and replace every single one of these assigned ones, because that will take me a lot of time. So what we can do, I can take my new still raw, I can click it, so I've got my left mouse button down, I can hold the option key, and hopefully what you can see is if I let go of my option key and then hold it down, you can see I get like a white highlight over the material. And basically what that means, if I let go, it now replaces itself over every single object that the original still raw material was assigned to. And so this is like a really handy trick if you're working with textures like these sort of textures, where they will be assigned to multiple different polygon selection tags. We can just now replace our material, and we can now build this up from scratch. And as we can see inside of our render view, it's assigned itself. So now what we can do, let's actually build this particular material. So we're going to come in here so we can really see what's going on. And I'm going to open up my new still raw, and I'm just going to dock everything again, you know, so we can all see what's going on. And then it would be a case of grabbing your texture maps from whatever downloads folder you have, whether it's, you know, directly from Unreal or Substance, or from the project files from Kitbash, depending on, you know, whatever stuff you're working with. And so I'm going to come into here, and I'm going to grab all of my still raw texture maps. And I'm just going to drag and drop them in here. And so we went through this process when we looked at part 2 in node materials. What we're going to do, we're just going to sort of, we're going to remind ourselves of that process. So we have our different texture maps. And so for this, we have, what do we have? We have base color, which is going to be like our color if we come into general. We then have our roughness map. We now have a metallic map, which is different to what we were working with node materials. We then have our normal, and we have our height, which is our displacement. And so the way that we put these together is, if we're wanting to build like physically accurate textures, or textures that look, you know, nice and lovely and photorealistic, we want to make sure that our base material, so our Redshift material node and our base properties, are set up in a physically accurate way. So because I want to create a metal texture, I'm creating a steel texture, I want to make sure inside my Redshift material that my reflection settings are suitable for a steel or a metal texture. And so for this, our BRDF for metals is naturally going to probably be GGX. And once we've changed this to GGX, we then need to adjust our Fresnel type. And so because we have a metallic or a metalness map, what we need to do, we need to open up the metalness input. And the way that we do that is by adjusting our Fresnel type from IOR to metalness. And you can see that made quite a big difference. So if I go back on here, if I change that to IOR, we keep an eye on how different this then looks, and we go to metalness, we can see that we're getting a very, very different result. And so let's start to just connect some of these and see what we get. So our base color, again, we do want to make sure that we adjust our color space. And so this was something we sort of briefly talked about in part 2. For base color, we want it to be sRGB. And then we're just going to plug this directly into our diffuse color. And now we can see it on here. So let's see how this is looking. Okay, so, I mean, it looks okay, but for me on my screen, I can tell that we're getting some sort of like strange projection up here where these sort of 2 polygons are meeting. And so what that means is we're going to just use that triplanar node that we went through a couple of weeks ago to sort of just fix those projection issues that we don't want to see. And so if we just type in triplanar and drag and drop that in here. So our triplanar, if we remember, it is a way of applying the same image or the same texture image to each axis, each of our X, Y, and Z axes. And then what it does is it kind of ignores the UVs, and it's going to project this accurately for us. And then we can even control like our blend amount to fix any issues that might occur on the corners. And so what we're going to do, we're going to connect this together. So it's going to be in between our texture map and our Redshift material node. And now we can see that it's fixed that projection issue for us, which is really great. It's a great little node to use. And the general rule here is if one of our texture maps requires a triplanar, then they're all going to need it, so they all match up. So all I'm going to do is I'm going to command click and drag, and it's going to basically duplicate and copy this node. And so I can really quickly just throw those in there, and then that's going to be set up for me. Moving on, now let's fix our roughness. So again, our color space for roughness, we do need to set to raw. And then all we want to do is plug this into our reflection roughness. And so now we can see that it's fixed that roughness there. So the metallic map, So where do we put our metallic map? And so what we did, we changed our Fresnel type to metalness. And what this has done, this has opened up our metalness input here. And what this then means is I can plug this now into my reflection. So it's still my reflection area. And then we come all the way down to metalness. And we can see that that has made probably the biggest difference inside of here. And so these values of our black and white metallic or metalness map are now controlling the input values of 0 to 1 on our metalness input. Cool, so let's just finish this. Let's finish this off and see what it ends up looking like. So we're using a normal map. So we've got a steel raw normal map, but as we saw in part 1, we don't have a normal map node, or we do, but it's a legacy one. Now we can use a bump map node, whether it's a normal map or whether it's a bump map. A couple of things we need to change. Our normal map, similar to our roughness map, does need to be changed to raw. And then inside of our bump map, we do want to change our input map type. So if we're using a bump map, so a grayscale bump map, we want to be using height field. However, as we're using a normal map, so we can tell because we get that it's sort of like that purple and green and I think it's like blue colors. We therefore want to be changing this to tangent space normal to ensure that we get that right normal map. Then all we have to do is connect all these together and connect it to our bump input. And now we can see that on here looking pretty nice. And I'm actually just gonna, I'm just gonna reduce this down to maybe like 0.5. It doesn't need to be like a crazy height scale. Could even go lower, but for now, I'm gonna leave it as that. Finally, we then have our height, which is our displacement. And if I'm being totally honest, I wouldn't actually set up displacement on this particular shot. And my reason for that is, one, displacement is going to add to your render time, naturally. That's just one of those rules. And if I go back to my original camera angle, I don't think you'd notice if there was displacement on or off these areas. I think when it comes to working with displacement, only use it if it's going to be really noticeable and really obvious. So in this case, maybe people may disagree, but I don't think that it would require the need for displacement. I think the normal map does enough because we are so far away. However, if we are wanting to set this up, just as a quick reminder, we can grab our displacement node. We then plug that into there, and our displacement goes directly into our output. So this isn't going onto our surface material. It just goes directly into our output here. And then the final step is, if we can select this object, we would then need to right click, go to, let me just go back into model mode. Right click, Redshift tags, Redshift object tag. And then inside of our geometry, we have to override our geometry and then override our displacement. And looking a little bit strange because of our scale. And so that's what we would do if we wanted to add displacement. But, as we said, I'm not going to worry about that. I don't think it needs it. So that's like a personal preference for you guys. Decide if it's something that you'd want to add, and that's how you would set it up if you do want to add it. But for me, I'm not going to worry about that. So that is how you would take these PBR maps from, let's say, Kitbash, and build up a metal material, build up that steel raw material. now what I want to do a similar thing, but we're going to create our screens material. And so there's a couple of differences between these two textures. First of all, as you can see, this is a metal texture, and it just uses these few texture maps here. And they're also just tileable textures. So someone actually asked a question last week about, what if it's a texture that's set up with the UVs, and you've got like the UV tag on your model or on your object? Well, that's why we're going to be looking at the screens texture maps, because if we open up the base color, you can see this is set up for the UVs on our different models or different objects. And so this is going to work absolutely fine inside of Redshift. So what we're going to do, we're going to come to create a new Redshift material, and we're just going to call this new screens RS. And then again, we're going to come down. And then again, I'm going to do my little trick. So I'm going to hold my new screens, hold my option key, and highlight it over my screens. And let's find where one is. I'm pretty sure there's one here. Let's kick that off. Okay, cool. So this is our screen here. So let's grab our maps. And so we have 7 different texture maps here. So I'm going to pull them all in, but I'm not going to be using them all, but let's pull them all in for now, just so we can take a look at what we've got. And I don't want to set up any paths, which is what I'm just saying no to there. So what do we have? Roughness, opacity, normal, metallic, height, and emissive, and base color. Okay, lots and lots of texture maps on this one. But there are a couple that we haven't seen before. So let's just quickly run through this, these first few. So again, base materials, absolutely fine. Because we're creating like emissive screen materials, I'm going to leave it on Beckman and IOR. So running through this slightly faster, I can't see the final one. We're going to go to, I'm hoping that says sRGB. Yeah. So let's plug these in. Diffuse color. And so because these materials and these objects already have the UVs set up, it's going to connect to the Kitbash textures correctly. So this doesn't matter whether it's standard C4D, whether it's Octane, whether it's Redshift, those are still going to work, and those UV tags are still going to work as normal. We don't have to, do any UV unwrapping again ourselves. I'm then just gonna, these don't have to be in a particular order. I just have a particular order of working. So I'm just gonna set up my roughness, plug this into my reflection roughness. And now let's take a look at these next two. So emissive and opacity are 2 texture maps that we haven't actually talked about over this workshop yet. So emissive, what do we have? Emissive is looking a little bit like the base color. However, what is white on the base color is now black on the emissive. And so what we're going to do, if you have an emissive texture map, this gets plugged into your Redshift material. And if we come down to overall, we have emission color. So if we remember, if we come back to our Redshift material and we look at our overall tab, we have this emission color and this emission weight. And so this is now controlling this input, so it's grayed out. However, nothing's happening. You're probably thinking, Ellie, it's not looking very emissive. It's like nothing happened. Well, that's because we then need to effectively switch on our emission by increasing our emission weight. So if I put in a value of 2, we're now getting this nice sort of like neon emission now based on the color of this texture map. And so we could go like, let's do like 4. Let's put it a bit higher. So that is our emission or our emissive texture map. And this next one's our opacity, because you're probably thinking, this is looking a little bit strange. Like this should look like just a normal light, basically, that's being kind of fired out. We shouldn't be able to see this big box. And so this is where an opacity map comes in handy. And if we take a little look at it down here, we can see these different black and white values. And these black and white values are going to be controlling our opacity. It's going to work like an alpha. So let me just plug that in here and back down on our overall tab. This is where we can control our opacity color. And as soon as I do that, we're now getting a way more accurate texture and a way more accurate look on in our final render view. So those are two maps that we hadn't looked at before, which can make a really amazing difference to especially like Kitbash models in this case. Cool, let's look at these next ones. So metallic. So we have a metallic map, which we don't really need to, we don't need to use, let's be completely honest. It's not a metal texture, so we're not worried about our metalness map. We can also tell that it's not really going to do anything because it's plain black. So that would just be a value of like 0, or yeah, a value of 0. So we don't need to use this texture map. We then have a normal, which I don't know if you guys can see through the webinar, but there's nothing on it. There's nothing there. And the same with height. It's plain grey. And so I would take the executive decision to not use these texture maps. Like if it was me, if I was creating this now, I wouldn't use any of these. I'd get rid of them because they're not going to make any difference to the final render. It's just going to add time to me, making this shot and making this render. So always kind of double check your textures. Also check, plug them in and see if you like the result that it creates. But to me, I don't think they're going to make any difference by just looking at them. And because I'm creating screens and neon signs, they don't really need to have displacement or anything like that. So I wouldn't really worry. These are the maps that are going to make this look as good as it looks right now. And it's going to save me some time. So without spending, any more time on that, because, we could spend hours just sort of building these textures up. But the idea of how we just went about these two materials is the exact same way that you would build the rest of these textures. So you would come in to your texture folder and you can see they're all named the right sort of names, and then you drag them in and you connect them and use the ones that you need to use inside of here. And then there are a few other textures I just sort of built that were just like plain textures. We had some smudged glass, and we're going to build our wet road now anyway. But Chad, were there any kind of questions on any of that stuff? I'm aware that we went through that a little bit quicker than normal, but it's because we'd already sort of looked at node materials. But I know people were asking a lot about, what if I have these PBR maps from X place?
Yeah, there's a lot of questions, so I'm trying to go through all of them and filter out what I can ask. There's a lot of questions of stuff that we're not really covering at the moment. Let's see, there was a good question. Oh, there was a previous there's a question I thought that was really interesting. In previous Redshift tutorials, they were saying, and Matt was saying that you had to change the gamma on the textures to 2.2, and now so far we've been leaving the gamma at 1. So
yes, that was an old. Yeah, so that was an older workflow before the the color management settings changed for ACEs and OpenColorIO. So that was an older previous workflow that we had to do, but now we don't need to do that. The only stuff we do need to do is changing the color space for some of those maps. So roughness and normal we change to raw, and then base color or diffuse albedo, whatever it's named, needs to be changed to sRGB.
Okay, so is the general rule then that things that are in color go to sRGB and then black and white maps go to raw?
Sort of. It's really just the normal and the roughness. So you wouldn't have to worry about the others.
Okay.
Just to get the correct color space out of them, basically.
Okay.
Without going too much into color management.
Yeah, for sure. And there were also a lot of questions about like setting up UVs, which is obviously like, obviously way outside of the scope of this course. But like, is there somewhere that you recommend for people to go to learn about like UVW mapping? I know that Cinema just like recently, like in the last year or so, like updated a lot of stuff as far as how it deals with UVs and stuff. So is there, I would imagine there's like some new features stuff somewhere around there. Do you know of anything offhand?
Yeah, so I don't know of any off the top of my head, but I guarantee there will be some on either Cineversity or on the Maxon Training Team YouTube channel. But what I could do, after this session, I can have a look around for some ones that are like up to date for like UV unwrapping. So I know that's quite like a big topic that we do get asked a lot of questions about. And so I'm sure we will have some sessions on that, and I'll put them on, I'll do like another PDF on the Dropbox link, because then everyone should have access to that, and then I can just basically link to those, because
Cool.
yeah, that would be a really cool topic to go through. But yeah, so what I'll do, I'll remind myself after this session, and I'll have a look through some up-to-date sessions, and yeah, I can link them for everyone.
Cool. Thanks, Ellie. I appreciate it.
Cool, no worries. Because yeah, it is a great topic, but yeah, it's also a rather big topic. Right, so let's get into creating this like wet asphalt ground texture, because it looks good, and we had a few questions about it in the last few sessions. So let's find a nice looking shot here. And I'm just going to create a Redshift material, and we're going to call it new wet. Let's call it wet road, just for speed. And I'm going to throw it on there. Let's see what we're looking like. Ooh, okay, right, super shiny road. Cool, right. So this is what we have at the moment. Let's open this up. So we're going to build this whole thing from scratch, basically. And it's going to be using a couple of texture maps from our good pals at, Ambient CG, that I think we talked about in part 2. So that's where I found a asphalt texture, which is this one here. So if I just go have a look at this texture here, this is what we're going to use. And I stuck with 4K. But maybe I should have gone 8K because it's quite a large surface area. But hey ho, we'll see where we get with that. And so my plan for these textures, sort of like what we talked about when we talked about node materials, is you have to start from what your base material would look like. So the way that I'd build this up is I would build just this asphalt road first. And then after that, then I'd worry about, okay, how am I going to create these puddles, and how are we going to sort of set that up? So first things first, let's grab our asphalt textures, and I'm just going to keep it simple: color, displacement, normal, roughness. That's all we need for this. And I'm going to drag these into here. Okay, so we've got our normal. And why is it not moving? There we go. And our displacement. Okay, right, so let me just quickly change this to, I can't see, sRGB. And I'm going to plug this into my diffuse color. And it's going to be like way too big, because it's just taking this one texture and mapping it over this entire surface, but we're going to deal with the scaling later on. Once we've set up our texture maps, we'll then do the trick with the math nodes that we looked at a few weeks ago. Now let's sort out our roughness. So, you know, the same stuff that we've just literally been taking a look at now. That makes a nice big difference. Then we're going to grab our bump map, and I'm going to grab my displacement just for speed. I'm going to connect these all together. Tangent space normal and input, and then this goes straight into our bump input. So I'm flying through some of this because it's repeating some of the stuff we've just looked at. So we've done that. Maybe we make this a little bit smaller. Maybe go like 0.2. And then our displacement. For this case, I do want to use my displacement because I want this to just add to the realism, and also our shot is going to be something like that. So we're going to be seeing that displacement quite a bit. So let me find my road here. And so I need to apply my Redshift object tag. And this is going to allow me to override my displacement. And then we're just going to plug that into my displacement here. Okay, so we can agree this is not looking very nice. And that's because what we need to do, we need to scale, effectively we need to scale down our texture map. So we need to tile it a lot more so we get a lot more finer detail. And, you know, I probably should have used an 8K texture, but hey, we'll see where we get with this. So we can use a math constant, and we can use this to control the different parameters of each of our texture maps. So we can use it to control the scale, the offset, and or the rotation. And in our case, what we're going to do, we're going to use it to control the scale. And the reason that I set these up is because once this texture is completely created, and I'm happy with its scaling and how it looks and its offset and whatever on here, if I then use this same material in a different scene, the chances are I may need to adjust the scale again, as well as maybe some other parameters. And this just means I can really quickly enter a new value without having to worry about coming into here and adjusting the scale of each individual one. So what I'm going to do, I'm going to put the value as 1 for now, which is the default value inside of our scale. And I'm just going to really quickly connect it to the scale values of each of my texture maps. So once that's set up, that's now done. So now what I can do, I can adjust this value, and it's going to adjust the scale of each of my texture maps. So let's go to something like 4 and see what it looks like. Okay, so it's already looking way better. Maybe I'll go to like 8. Yeah, that's looking all right. That's looking okay. Hopefully you guys can see that. Maybe I'll try and make this a little bit bigger. So we can see, because we've then scaled, we've changed this scale value from 1 to 8, we're getting a much finer and a much better looking shot in my render view. So the next step to be, now we've created this asphalt road, now we've done this part, it's going to be how we're going to create our puddles and get those nice reflections. Well, the first thing we're going to do, let me just create some more room again in here, is we need to set up a material blender. So this was how, so if we grab ourselves a material blender and we're going to pull this in here, this is where we can add different materials and layer up different materials, and then we can use blending colors, i.e. blending masks, to mask between those two materials, those two textures. And this is a really cool way, or a really cool technique of setting up these puddles. So what we can do, we're going to drop our material blender in between. So we're going to put our asphalt material between these two here. And so we're going to drop that in there. And so nothing's happened. And that's because we've used this same material as our base color. And that already was our base color. So that's cool, that's done. But now we need to define our secondary color. And this is going to be the one that's going to look like our puddles. And so the way that I did this, there's so many different ways that you can do this. But the way that I did it was, I'm just trying to create some more room for myself. Let's move this, let's move these down. So I duplicated my original material, but with none of the texture maps on. And then I'm going to use the color texture map, and I'm going to plug that into my diffuse. And so if I plug this material now, so what we've basically got the exact same thing, but we haven't got any of the reflection roughness or any of the bump. And so if we plug that into my surface, this is what we get. So we're taking the color still, and that's how we still get that look there. But then because we have no roughness, we're getting this really kind of like shiny, glossy, wet looking floor. And so that's going to be our layer color 1. So we've set up our normal, realistic looking rough asphalt road. And now we've got our like super shiny version. And then all we need to do is to define our blend color, which is our blending mask. And this is where we're going to be using those puddle maps. And so let me find these. So inside the project files, there should be some 4K wet maps. And there aren't that many, like there are only 5 of them, but they're all 4K and you can use those in this kind of situation. So we just sort of like open these up just to have a little look at what one looks like. So these are super simple to make. So I just created these in Photoshop. And I've got like a set of brushes which are called, I think, like smoke brushes. And then I just did that, and that. And then, yeah, really simply. And they work really, really well in this situation. And so which one did we use in the end? So this one here. So let me just take this. So I'm going to drag and drop this into my shader graph. And no, we don't want a path. And what I'm going to do, I'm going to connect this to my surface just so we can see how it's projecting onto here. Okay, so we need to adjust the scale a little bit because we can't see anything here and it's not going to look very good. And so inside of my puddle map texture, I'm just going to sort of mess with my scaling a little bit just to see what we can get. Okay, cool. That's looking cool. I like that. I might leave it at that. So I've just changed my scale to 3. So we now have 3 of these sort of being tiled along this whole surface. And what we're going to do, we're going to use this black and white wet map or puddle map or whatever you want to call it to be a mask between these 2 materials. So where these black areas are, we want to be looking like some wet puddles, and then where the white areas are, we want it to be sort of looking like a slightly drier, and then the grey is going to be like a grey, a sort of like an in-between of these. So let's plug that straight into our surface. Let's wait for that to update. And then we're going to plug this straight into our blend color 1 in our material blender. And it's the wrong way around. I mean, it still kind of looks cool. I quite like how it looks anyway, but I'm actually going to invert it. And so the way that I can invert these black and white values is just by putting a ramp between my puddle map and my blend color, and then hit that invert button. And now we're getting where these sort of like black and grayscale areas are, we're seeing this, the shiny texture, which makes it look like we're getting some wet puddles. And the cool thing about using the ramp is we can then dial in these values even more. So I could start to pull my black handle across, and then we're reducing now the amount of sort of like wet puddle we have. Or we can do the opposite. That was the wrong button. We can do the opposite and now pull out even more. So we have more of these happening here. And something I would do, something else I'd do is, so let's sort of pull this over here. I'm actually going to use this puddle map as a bump on this second material as well. So this is just another thing that I like to do to add like another layer. You can plug that into here. And so now we're getting some extra sort of like bump detail effect. And then the last thing that I would do is I want to make this base color darker. So at the moment it's a little bit too light. And so the way that I would do that is by using a color correct, plug that into my input, so my color map into my color correct input. And this is a great way of sort of using materials that you already have and just messing with them a little bit just by messing with the colors. So if you have like preset materials or pre-made materials, or you use maybe like Grayscale Gorillas, Redshift materials for your work, like you can really easily just make them look completely different by dropping a color correct on the base color or diffuse, and then just sort of like messing with these settings. And so to make it darker, I'm just gonna mess with the level scale. I'm gonna pull that down a little bit to make it a little bit darker. And so here we have our really lovely looking like wet floor, and we get those really like great looking reflections as well, which I think just adds to this shot a lot. And so what we can do, so I've come out of my shot and I've got my final looking thing here, and I'm thinking this is looking a little bit plain. And so what we can do, we can come back into our puddle map. You know, we can mess with our scale if we want. We can mess with our rotation. So if I start to adjust my rotation, we can see we're getting a different effect here. Then we can mess with our offset, and you can see how this is updating, and it's just changing the offset and the rotation of this particular texture map. Cool. So that was how I went about building that that wet floor texture. Right, I'm just thinking time-wise, what could we go into? Okay, no. So do we have any questions on that particular thing, Chad, before I move on? I want to make sure I get to all the things that I committed to going through.
No, I think we're good. I think we can keep going.
Sweet, cool. So yeah. So far what we've done is we looked at how I went about lighting this. We'd also add some area lights if we want some volumetric lighting, or just to kind of add to some secondary lighting setups. And then we looked at how we can put together our PBR maps for these different textures and how we can replace and assign these different materials. And so, you know, we're not going to go through every single one, but the ideas are the same and the technique is the same. It just takes the time to actually create them and actually do it. But the amount of time it then saves you in the long run is it's totally worthwhile. So now I've got all of these textures. I've converted them all for Redshift. Now, if I create something in the future with them, they're done, they're made. It's not going to take me any more time, just maybe a little bit of like tweaking with the scale or tweaking like the bump map height. And so as much as it can seem like a pain to convert these materials, it saves you time in the long run. So it absolutely is worthwhile.
And you mentioned,
and then we just looked at,
oh, sorry.
Yeah.
You mentioned
you
the materials, like once you do it once, you don't have to do it again. Is there a way to like, I don't know, create like a library of like Redshift materials? Can you create your own presets that would link to your external textures and such, or?
Yeah. So in the asset browser, we can add materials to database. So we can set up our own lovely little database of Redshift materials, and then they'll be inside your asset browser to use.
Oh, the asset browser. That's amazing. Oh, one other question. Megan had a great question about, you're using the constant to drive like the scale value, but scale is like a vector, right? So like, but by default, it just has like this one single value. If I change the data type to vector, can that allow me to do a non-uniform scale? Or what would you do if you wanted to control like a non-uniform scale?
Yeah, so absolutely right. Answered the question already.
Yeah. Woohoo!
They answered it with their own thing. Yeah, so you can then enter different values inside of there. And then of course, you don't have to use the constant. You can still come into the texture maps and you can highlight them all and adjust those different scales as well. This is just something that I like to do, just to show an extra node, and it can save you a bit of time in long run.
Okay.
But yeah, adjusting that data type, as you can see, there's loads of different ones inside of there.
Now, since we're here, Marco had a really great comment, because he said that you could set up a custom keyboard shortcut to connect things automatically. Like I think he said Shift V or something like that. He uses to like automatically connect a line to like the output or something like that. Are there like shortcuts for Redshift, or like are there things that people use in order to, like, I don't know, create nodes faster or connect them faster, or is that just kind of like part of the deal?
Yes, so I'm not sure if you can set up shortcuts in the shader graph. I mean, you may be able to, but inside of tools we have like this connect node to output, and so you can set shortcuts for these.
Gotcha.
For these particular things in here. But
okay.
I mean, some people may use Cinema 4D's node editor, and therefore there's like a really handy button there where you can solo a node, or you can connect it straight to the output on the actual node itself. But yeah, you should be able to, for these particular options, you can then set up a shortcut for those. Oh, it's going to be
okay.
I have not done that, so I'm trying to figure out where I would do that. If anyone knows.
No, that's cool. I was just wondering if there's like kind of like some kind of like secret trick, like after you've been doing Redshift for a while, like these secret codes of like how to do blah blah blah, whatever. Anyways, I've derailed you enough with like side comments.
No, it's okay. No, so I don't set up shortcuts because of training purposes. I try and use as few shortcuts as possible.
Great.
But I'm positive there is a way, as they were saying, to set up these ones. Or if you use C4D's node editor, they have like those shortcuts already on the nodes, which I'm very jealous about.
Cool. Thanks, Elly. This is such great stuff.
Oh, thanks. Cool. Right. So let's take a look at some post effects, because we didn't have time to look at those last week, and they're pretty cool. So where shall we look at them? Let's pretend that we've just made this lovely shot here, and then we're going to kick off our render view. So hopefully with that information that we've just learned in that first hour, you guys, so it's pretty much the same thing, just it then looks like this. All I did was build those textures in the exact same way we just looked at. It's the same floor texture, a couple of area lights and some volumetric lighting, and then it literally looks like this. So hopefully, with that info, you guys can start to build up your own like cyberpunk scenes from some of that Kitbash stuff that we have, or just take all the textures that I've already converted and assign them. You don't have to worry about converting them now because they're all done for you. So let's take a look at post effects using this render, because they're always going to look better on a cool looking render. So what are post effects? What are they and where can we find them? So first of all, post effects are a couple of post processing features which come inside of the Redshift render view. And so let's have a look. Where can we find them? So if we come up to view in our render view, so first thing we'd want to do if we haven't got it open already is come to Redshift render view, and that's going to open up this lovely window here, which I have then docked. And then we can come to view and settings, or shortcut O. So if we hit that, we then get given our different display options, including all of our different post effects. So if we kick off our render view, just so we can see, let me move this all the way along, just so we can get a nice visual of everything. And actually, do you know what? For the sake of speed, I'm going to switch off my volumetric lighting. So I'm going to switch off my Redshift environment, just so we can see this update a little bit faster and a little bit clearer. So color management is a huge topic, which we're not actually going to talk about. However, Chad, I was wondering, would you mind, if for anyone who does want to know more about color management, drop Chad a message in the chat. And then Chad, could you find these managing color things on YouTube, series sessions on YouTube? It's basically just on the Maxon Trainer Team YouTube on demystifying post-production. And so for anyone, because we have had a lot of like color management questions, and this is a massive topic. As you can see, it was covered over 5 sessions, and it goes into so much detail about ACEs, Open Color IO, in particular inside of Redshift. And so if it is something you want to know, let Chad know in the questions area, and he can link you to these. And it goes through in so much detail about this incredible stuff all about color, and it's run by Max, and you've got Denoising in there, and you've got Lionel in there as well. And
also,
yeah,
just a little sneak preview. This is like, I don't know, maybe I shouldn't be talking about this yet, but Max has his color show, Max on Color, like the 1st and 3rd Thursdays, I think, of the month. Max on Color, this new show.
Yes.
And we're working behind the scenes with our buddy Dr. Sassy, who is a genius about everything that you could be a genius about. And we're doing a kind of like a soup to nuts basics of color science, and so that's starting from scratch. So that's coming up in the works in the future.
We've got an exclusive. I love sort of like announcing things on these hands-on sessions that we maybe shouldn't say.
Surprise.
No, who's gonna know? Cool. Yeah, so anything to do with color management, check out those tutorials, and yeah, check out Max on Color, Max's new show. So let's dive in at some of these different post effects. So we won't spend too much time on here, but it's going to be a cool thing for us to look at. So let's have a look. So LUTs, lookup tables. So some of you might use LUTs before, whether you use them inside of, I don't know, like Photoshop, or use them inside of Lightroom. Well, you can use LUTs inside of the Redshift render view. So all we have to do to enable this post effect, we just got to check this little button on, and we can enable it. And then we can choose, our LUT location. Redshift actually has a bunch included, which is quite cool. And then all you have to do is hit this drop down, and you can choose, oh, look, we've got lots in here. You can choose the particular LUT that you like. And you can just flick through these, see what you think looks cool, etc. Let's leave that on for now. And then we can adjust our LUT strength inside of here. So this is just, doing a color transform on our render, and it accepts .cube and .3dl, I think, LUT files. So we can do this stuff inside of here. We then have some different color controls where we can adjust overall color, brightness, and things like that. So we have exposure and contrast, which we can be messing with, as well as like our curves. If I can actually click that, that'll be great. Cool, there we go. Cool, look, so it's looking, it's not looking that great, but for the purposes of showing these post effects, I want to make everything look a bit more dramatic. And then we can switch that off again. And then if you're used to working with like camera controls, if you're used to working with like ISO and f-stop and things like that, we can actually adjust these global controls directly inside of here. So, you know, we're not going to worry about going through these different things, but we can make these adjustments as well as adding some, you know, stylized vignetting, as well as doing some of our black rush. And so it's going to control, you know, what happens in the darker parts of our image, and it's going to sort of like squash those darker colors or darker areas to add more contrast. So if I start to increase this, so this goes on our threshold and our amount. So if we have like a no threshold, this isn't going to do anything. If you have a really high threshold, it's going to be affecting a lot more of those darker areas. So those are sort of like our color controls. These next few are maybe more stylized visual effects that you can add to your render. So one question we did get a couple of weeks ago, I think, was about, okay, how do I create like a glow? So if you have like an emissive material and I create a glow, like in standard material editor, we have a glow channel, right, in the material editor, so we can switch that on, and it's like a post process that happens afterwards. This is a similar kind of effect, it just looks a little bit better. So if we check on bloom, the first thing we want to do is adjust our bloom threshold. And so all of these settings you'll see pretty similar, right? So they're all sort of the same kind of effect. With the threshold, we actually want to go down. So I'm going to pull this down, and hopefully you can start to see on these brighter or lighter areas, we're getting some of this sort of glow happening. So if I pull this, just for the sakes of demonstration, I'm going to really exaggerate these effects. So I'm going to pull this down, and then my softness is the softness of our glow. We can then tint it if we want to, whereas by default it's tinted by the light or emission that's sort of like causing and casting this glow. So you can see this neon sign is giving us a pink glow. We're getting a bit of a blue one here, and then we're getting a white one up here. And then we can up our intensity to get a really cool dramatic glowing effect. Flare works in a similar kind of way. We have our threshold. We then have our softness, bit of like chromatic aberration going on. Then we have some like sizing options and the halo options, and then again our intensity. And then finally, the last one of these sort of stylized post effects is the streak. So what this is going to do, it's going to add some streaks to these different lights here. So we can increase or decrease the tail. Again, softness, streak number. So we can go a bit crazy with that, as well as our angle and our intensity again. So these post effects are just like a nice way of adding, I don't know, some like color grading or some of these like glow effects. And I mean, you know, we dramatize these just so we could demonstrate them. But if you don't have other software like, I don't know, Photoshop or After Effects, and you do want to get into a little bit of color grading or color correction, or just some little tweaks, some stylized tweaks like this, then what's really nice is we can do this inside of Post Effects, inside of Redshift. And I mean, for me, I do a lot of my stuff in post, so I don't often use these post effects. I just sort of want to do like a little disclaimer. So yeah, I do a lot of my corrections in Photoshop if it's a still, and After Effects if it is a animation. But there is nothing wrong with using some of these settings, or even just to get an idea of how a shot would look with like a LUT over it or something like that, or a little bit of glow. The only downside I would say to these is we're going to look at AOVs later on, which are multipasses, is they don't have a post effects or a post processing AOV. So once you make these changes, it's on your beauty render. So it's on like your final render set there. It's not, you don't get like a separate pass, which would be like really, really great and really cool. So we could then adjust these post effects in post as well.
Well, that's really good to know.
Yeah, Chad, I don't know how you feel, because you do a lot of like post and compositing, way more than I do. So
Yeah,
what do you think about these sort of effects?
Yeah, I would definitely. That's a bummer because I think they look really cool. Like those blooms, the flares, the streak things look really, really cool. But then if it's baked in, that does limit how flexible it is in post. So I'd probably avoid using those in most cases. Now, just really quick,
Yeah.
quick question: is there something? Is there like any kind of like scope or like out of gamut warning? So if like you're oversaturating something, or if you're blowing out highlights or crushing shadows, like anything that kind of like indicates that you're losing detail with the post effects here?
I don't know.
Okay,
I
haven't
haven't
heard of
anything
or
in the
seen anything
past.
before. Yeah.
No, I've never seen anything in the past, but I wouldn't like to say no without knowing.
Yeah, for sure. Okay, cool. This is really cool stuff though. Thank you.
No worries. So yeah, I'm glad I wanted to show a bit of post effects, because I know that was it was supposed to be a topic discussed last week. So yeah, I wanted to show those because, you know, like we do get some cool effects, but yeah, it does have its limitations. It does have its potential, not issues, but I mean, it would be great to have the AOV basically. That would be wonderful. Okay, right. So what have we got? Ooh, okay, it's right. We've got time. So let's dive into some slightly more advanced render settings. So what I'm going to do, I'm actually going to open up. I feel like I keep coming back to this trusty getting started file. This is a nice,
if it works, you know.
if it works, it works. It's just nice to show, and it renders quite quick. I think that's why I want to show some of these render changes with this little final project file. Okay, right. So let's get into render settings. So first of all, where do we find our render settings? So inside of this little button up here, we have what looks like a bit of like a clapperboard and a cogwheel. If we click that, we get our render settings. And so I would imagine if you're then getting to the point where you are adjusting your render settings, your renderer will already be set up for Redshift. Because normally what you would do before you create your lights and your materials and use Redshift and the render view and the IPR, you would change your renderer first. So we're going from a point where this renderer is already set up. So once we've set up Redshift, we then have our Redshift tab. And in part one, so when we did like our getting started, we looked at the basic mode tab inside our render settings. And so what our basic tab is it gives us all of what Redshift would class as the most important getting started settings when it comes to creating a render. And so we looked at these different options and we broke those down. So we had our bucket quality, our threshold, denoising, and our GI, and our different sort of our ray depths, which are these sections here. And there is nothing wrong with using the basic tab. It is really great for a fast render. Maybe if you're working with like motion graphics, you could absolutely work inside the basic tab. And especially if you're first learning Redshift, you can get some really, really great results out of the basic mode without having to worry about going into, you know, fine tuning all of this other crazy stuff inside of our advanced tab. But let's say you've been using the basic tab for a while, and you want to move on now and you want to start learning some of the more advanced render settings, or just sort of like the more fine-tuning render settings. And in that case, what we'd need to do is we'd need to come over to our advanced tab. And so these are just different buttons that you click and it opens up the different options. So if we click our advanced tab, we then get given a bunch of different tabs. So we have sampling, motion blur, globals, global illumination, caustics, AOV, optimizations, and system. So what we're going to do is over the next kind of 25 minutes, we're going to dive into some of these advanced render settings. We're not going to be going through every single one, but we're going to be going through what I would say are the most commonly changed advanced render settings, and the ones that would be like really great to learn if you're coming from the basic tab or coming from standard C4D and you want to start, you know, start getting into some more advanced render settings. So sampling, let's have a look at, let's just start from the beginning. Let's have a look at our sampling. So what exactly is sampling? So what are samples? And so what happens is Redshift will fire samples to each pixel, and the amount of samples it fires depends on a couple of different things. It can work this out automatically, or we can set up a minimum and maximum number of samples. And basically what happens is the more samples that get fired out, the less noisy and the cleaner and the nicer looking our render is going to be, but with the, you know, increased render times as well. That's kind of like a bit of a rule. And so that's what we mean when we talk about samples and sampling. And so we'll talk about unified sampling in a sec, but we may as well just go through some of these other little options just to see exactly what they are. So this first sort of section is our rendering modes. And so what I'm going to do, I'm going to kick off my Redshift render view, and what we can see down here is we have this little progressive rendering line, and then we have this sort of percentage bar. And what is happening is our Redshift render view is progressively rendering our scene. And this is because inside of our interactive rendering option or mode, we have progressive set up. If I was to change this to bucket, watch what happens in our render view. First of all, we now have bucket rendering icon switched on. And now we're getting a bucket render. So what's happening is it's rendering each of these squares, which is known as a bucket. It's doing a full render of each one. And then what happens once it's done every single one, the whole render's done. Whereas progressive, what it's doing is it's going to progressively do multiple passes, which will start noisy and will get progressively cleaner and cleaner based on our progressive passes. By default, your interactive renderer is set to progressive, and I think that's like the best method. And the reason it's the best method for interactive rendering, so our render view or our IPR, is because you would get really, really fast feedback when we make changes to our textures or to our lighting. And so what we mean by that is I can switch off my dome light and I get an update like that. And switch it back on, I get an instant update pretty much. And so when we're working and building up our scene and building up our lighting and our materials, we want our render view to be fast and to be kind of showing us these updates. I don't want to be waiting for a bucket render every single time I tweak one setting. And so progressive rendering is really good for that. There may be some instances where you may want to bucket render like a particular area, and you can use your interactive render region for that. Or if you're working with, I don't know, maybe like subsurface scattering, for example, you will get a more accurate result with bucket rendering. But I would stick with progressive. And then final rendering, as we can see, by default, it's set to bucket, which is, you know, the higher quality final render mode that we're going to want to go for. And this progressive passes only relates to the progressive mode inside of here, which is on our interactive rendering. So this is going to be, you know, this will be the maximum number of progressive passes. And once it hits that, then that's as clean as and as nice as our render is going to look inside of here. So those are what those settings mean. moving on to unified sampling, and this is quite a big topic. Let me just switch that off for now. So automatic sampling by default is actually switched on and is inside here. And this came about as this became the default, I think it was early last year. So before, we used to have to set our min and max samples, and then we also had the ability to control sampling overrides. Now we have automatic sampling on by default. And so what it does is Redshift automatically works out and optimizes the sample count per pixel. And so what it does, it's kind of simplifying this whole process, because it means we don't have to worry about manually tweaking sample counts. And so the minimum maximum number of samples that are being fired per pixel is controlled by Redshift in relation to the amount of noise that is in our scene. So what it's going to do, if there is a noisy, if our scene is noisy, or there's a noisy area of our scene, it's going to automatically fire more. It's going to know to fire more samples at that area than a different area. And so, you know, it takes a lot of the work from us. But the important thing to mention with automatic sampling is this threshold is very important. So the threshold controls how sensitive or aggressive our automatic sampling detection is. And so basically what we mean here is, if we have a lower threshold number, Redshift is going to detect our noise and our grain more aggressively, and therefore it's going to fire out more samples or more rays per pixel, which results in a less noisy final render. But it also results in a slower render. So the lower the threshold, the better quality our render is going to be, but it's going to take more time. That's just the natural balance when working with any kind of renderer or any kind of rendering. It's, you know, time versus quality, isn't it? And then higher numbers, so I'm talking flip side, if we go higher numbers, Redshift is going to detect that noise less aggressively, therefore fewer rays are going to be shot per pixel, and therefore you might get like a more like noisy looking scene. So let me just change this back to the default. One really cool thing here is we have this show samples option. What we can actually do inside of our render view, we can actually change this to show our samples, and it's going to change to bucket mode by default because we need bucket mode to see our samples. So just let it do its thing quickly. What you can see is we now get a sort of like a grayscale render, and what it's doing is the darker areas are fewer rays, and the sort of like the grey and the whiter areas are the areas that need more rays to create a less noisy shot. And you can see it's the ones in the creases, or maybe have got less lighting. And so this is always a handy way of seeing where we're getting our samples. Okay, so we'll talk about these final two, and then we'll look at overriding samples as well. So random noise patterns. So we had a question in week 1 where someone said, if I create an animation, will the noise pattern match frame by frame? No, it wouldn't. And that's a good thing. And that's because our random noise pattern is enabled. And so we wouldn't want the noise pattern to match frame by frame, because if it did, it would look like we have like static noise or noise on which will be like stuck to the lens of the camera. And so what we want is a random noise pattern when it comes to, especially when it comes to rendering an animation, to make the noise look more like moving static or you know, like grain, and it will just make it a lot more visually appealing. And so this is what this setting does, and it's enabled by default because that's naturally the effect that we would want. And then finally, the filter option, just to sort of like briefly go through that, it's how these samples are going to be merged together based on this filter. So we have this is like our blurriest filter, this is our sharpest filter, and then by default I think it's gauze, and that's the most neutral looking filter with the ability to adjust our blurriness, size, and intensity in there. Okay, so right. So some people, if you've worked with Redshift before, might be used to or may want to have access to sampling overrides and setting up our minimum and maximum number of like sample rays. And so the way that we can access that stuff is by unchecking automatic sampling. So as soon as I uncheck that, it opens up a bunch of new settings. So first of all, it opens us up our samples min and max, and then secondly, it opens up our overrides option. So inside of here, our samples min and our samples max, by default, they're set to 4 and 16. And so samples min is the minimum number of arrays or primary rays that are going to be shot per pixel. And then the samples max is the maximum number of rays that are going to be used on those areas that require more rays. And so what we mean by that is every single pixel gets four samples. But let's say that pixel is still, after those 4 samples, it's like, look, Ellie, I'm still noisy. I need more samples. You go, okay, cool. You can have some more samples, but you can only have a maximum of 16 samples. So what it's going to do, it's going to keep taking those samples until it is noise free, or until it hits this maximum number. So whichever comes first, basically, is what it's going to do. And so these settings will depend a lot on the scene that you're creating and the stuff that you're using in your scene or your animation. So for example, if you're working with depth of field, something we looked at last week, the recommended number of minimum samples is 8 or 16. And then the maximum is something like 256. So you're going to want to make sure you up these settings based on the things that you're using inside of your project. And this will come with tweaking and experience, I guess. I use automatic sampling more than I adjust my min and max samples. But yeah, the general rule as well is to keep these numbers, I don't know what the word is for them, but you know, like 16, 32, 64, 128. We want to keep those sort of values for these as well. And then we also have the ability to override our samples as well. So what we can do, we can apply global overrides or global scaling to the number of samples for these particular ray types. So what we can do is, let's say I want to override my reflections. I'm going to enable my reflection overrides, and then I'm just going to drop this down. And so we get given 2 different modes. So we have replace and we have scale. So the replace mode is basically going to replace any reflection sample number with this new number. And so let's say by default, our reflection samples inside of, like our materials are set to 16. So let's just really quickly show where you can see these. So inside our Redshift material, so, over the last few weeks, we've seen that lots of things in Redshift have this samples option. Lights have it, materials have it, and this is where we can tweak each of these. But our overrides is where we can override all of those values in one go. So as we saw, the default there was 16 samples. So let's say in my reflections, I want to replace every single set of reflection samples to 64. What it's going to do, it's going to completely override what is in that value or in that input now, and it's going to replace it with 64. So that's what replace overrides will do. Scaling overrides, scaling, I don't really like the word scaling because it's kind of like a multiplier. And so what this means is it's going to take a look at that value that's in that sample setting, which was 16. And if I set my scale to 2, it's now going to override it to 2 times that value. So it would therefore become 32. And so those are the different modes we can adjust our samples, or if you've adjusted your individual inputs, you could then scale them up if you find it's not enough. So that's sampling, automatic sampling, overriding samples. There's a lot to kind of look at and lot to kind of to tweak and to mess with. For me, I personally use automatic sampling. There have been some instances that I've done sampling overrides. For example, if it's got like a lot of like fog or volumetric lighting, I may override my samples for that. But sometimes I do find, and this is just my experience, this isn't like an actual like fact or anything, that overriding samples and setting min and max can increase the render time because it's not as optimized. But maybe it's because I'm not as experienced with it. So yes, that is sampling inside of Redshift. And I do want to talk about, before we sort of move on, denoising. So I feel like I maybe didn't do denoising justice when we talked about it in the getting started week, because I think, yeah, I feel like I badmouthed it a little bit, and I'm going to take it back. I'm not going to lie, I'm going to eat my words. And the reason I'm saying this is because we had a question that I loved, and it then led me to doing some tests and some research, which was in week 1, somebody said, is there, or can you get a motion graphics animation or render inside of Redshift for less than 30 seconds per frame that looks like, you know, like pretty good, like it looks all right? And I was thinking in my head, I was like, oh, I don't know, like, but I wanted to try it. I wanted to test it out. And so I did some tests. So I made this little Friday motion graphics animation. And so I was like, I'm going to do some tests on this animation to see if I can do it. And so let me go into Photoshop. Okay, so let me come up here. Right, so what I did was, this is all basic tab, all default settings. And I wanted to test out some different things, some different settings on, like, you know, sampling, denoising, and global illumination. And so let's have a look at this one first. So we can all agree this one is looking pretty horrendous, right? It's really grainy, not very nice. 14 seconds per frame, but it looks awful. So we don't want that. And so that was low bucket quality. Denoising was off, our GR was off. Everything else was just default, right? And then we're going to come over to here. Same thing, but we've got our global illumination on. And so our global illumination is, we're going to talk about this later on, is our light bouncing. So we can see we get, you know, we've lightened up these darker areas, and we're getting a nicer looking sort of color, but we can still agree. Super noisy, super grainy, even though it's 20 seconds per frame, no one's going to want to look at this, right? And I can say it because this is my work. I'm insulting my own work. Okay, so this next one is the exact same thing with denoising on. I think it looks great. I think it actually looks really good. And it was 29 seconds per frame. M1 Max, MacBook Pro, just to clarify. but I think this looks great. And I mean, you know, we could pick at it and I could say, oh, I'm not really sure at this stuff here, but this is a still of a motion graphics animation. And so it's easy for us to kind of like pick on it. But 29 seconds per frame, I think, so I need to take back whatever I said before about denoising, because it can give you really great results really, really quickly. So I'm going to say, yes, you can get a motion graphics render in under 30 seconds per frame, because I don't think this looks too bad. So it was fun to test out though. And then, you know, I increased the bucket quality. So we increased our samples and our threshold to get a cleaner result. And we got our denoising on, our GI on, and you know, it does it nice. It cleans up some of these areas, especially some of these like shaded areas. But then it's like 1 minute 22 per frame. So that's still not bad in comparison to, I'm sure, some other results. But yeah, I think that as an animation would still look fine. So slightly off on a tangent there, but I wanted to talk about like how denoising, you know, it can work for certain situations. If you've got an abstract render, an animation, a MoGraph animation, I would say denoising will work for that. Maybe if you're doing photorealism or a landscape shot and things like that, I would perhaps avoid denoising because you can lose some of your quality. In that case, yeah, I would just stick to adjusting your samples as opposed to your denoising. So yeah, hopefully that answers that question that someone had in week 1 in a very long-winded way. Motion blur, I don't think we're going to go through that. I'm very aware that we have 15 minutes left. So I'm not going to worry about going through motion blur because there are some other important options, which are globals, GI, and AOVs, which I want to get to. But if you want to know more about motion blur, Redshift documentation, it's just sort of like enabling it, controlling your steps, which controls the trajectory of the camera. And then if you have deformation going on, we can do that as well. Cool, so globals, trace depths. Let's take a look at these. And so we're not going to worry about these settings. These are the ones we're going to focus on. And in the basic tab, we do actually have access to these. But what exactly are they? So what are trace depths? So they are the maximum limits for our ray types, our different ray types. So for example, our reflections and refractions and transparency across our entire scene. The important thing to mention here is increasing our trace depths can more often than not greatly increase our render times. So the general rule here is to try and limit and have as few as you need, but to achieve the best result possible. And this will depend on how your scene is set up or what you have in your scene. So if you have loads of glass and loads of refraction going on, you're going to need more refraction trace depths. So trace depths are bounces. That's what we mean by trace depths. And so reflection is how many times a reflection ray is going to bounce in and around your scene. Refraction is the same thing, how many times a refraction ray is going to bounce or pass through an object. And then the combined tab or combined setting specifies the maximum like number or maximum limit for your GI, reflection and refraction rays combined. And so what we need to do if we start to adjust these particular settings or we increase these bounces, we're going to want to make sure that our combined depth has been upped as well. Otherwise, we're going to get it's going to be capped. And then we have the same thing for transparency, which is how many times a transparency ray can pass through an object. And this isn't affected by this combined parameter. So this isn't going to be limited. So yeah, depending on what you have in your scene, you may want to up your particular ray bounces in this area. This leads us into GI, so global illumination. So for anyone who isn't sure what GI is or what global illumination is, in the real world, when light comes from a light source, it then bounces off the surfaces around us, and then finally it hits our wonderful eyes. In Redshift or in 3D or any kind of like graphics, GI is a simulated version of this light and this ray bouncing. And what it does in turn, it just adds some realism to our lighting, and it's going to help us to achieve some more realistic results. So what we mean by that is sort of like if we have a light coming down here, we then want it to bounce and then light underneath in here. If we just kick this off. So we then want the light to come down and to sort of like bounce on, hit this surface here or this surface or this surface, and then come up and continue to bounce to light this scene. And it works quite nicely in these sort of like shaded areas. So if I disable this, hopefully it can be seen more in there for that. So any light that hits a surface straight away is direct lighting. Anything that then bounces off one or more surfaces is indirect lighting. So global illumination effectively is controlling or simulating indirect lighting. So inside of our settings, what exactly do we have in here? So for a start, we have the ability to enable and disable GI, much like we can inside of our basic tab. The next step would then be to choose your primary and your secondary GI engines. And so when the first rays, like camera rays, hit an object, that's our primary GI. If it then bounces or these rays then bounce, this is when we use our secondary GI. And so we can look in detail about these different GI engines. We won't because of the time for now, but I'd recommend looking at the documentation to see the differences between them. Irradiance cache can be faster, but you can get flickering for animation. Brute force is slower, but it is more accurate, and you don't get flickering for animation. And you also have less controls on brute force. We then have trace depth, which are our GI bounces. So if you hear someone refer to things as GI bounces, these are our trace depths. If I put this on 1, you will see we don't have a secondary engine because we don't have any secondary bounces. So we don't have the ability to control that. As soon as we have more than 1, we then have the ability to adjust our secondary engine. GI bounces will result in your scene being lighter and brighter because we get more light bouncing occurring. Be careful to not go too far in the other direction because this can wash out your scene and create too much light bouncing, and it's also going to increase your render times. I think by default it was on 3 or 4. If you use Grayscale Gorilla's Redshift textures, they recommend you use a trace depth or a GI bounce of around 5. So sometimes you might find if you're working in a certain way that they will give you a recommended trace depth, or just see what works for you. And then again, secondary engine. And then with brute force, we then have our brute force rays. So this is the number of GI rays that are going to be shot out per pixel. The higher the number of rays here, the cleaner and less noise the result is going to be, but longer render time. So that was really quick about global illumination, but I would recommend having a look at the documentation for the different GI engines in particular. It's got a whole list of pros and cons. It's got a good sort of recommended setup for the different things that you're working with. And it also goes into detail about the different IPC and irradiance cache settings inside of here as well. Okay, I'm flying now because I want to get to AOVs. Okay, so for the sake of this, we're not going to go into caustics. And I don't think we're going to go into any of this either. The only thing I do want to say, in the system tab, you might find if you're working on a lovely high spec machine and you're rendering, it might say to you like, hey, you've got a great GPU, probably not in those words, and it would probably recommend you increase your bucket size. And this is where we can do that, because I know I had a couple of people email me about this, so I didn't want to talk about this. Inside of the system tab, drop down bucket rendering, and then we have the bucket size. By default, it's 128. And so if I hit bucket render on here, you can see that we get our little buckets here, our little squares. If I change this to 256, what it does is it's going to be a bigger bucket. And what it's doing is if you have one GPU, it is working one bucket at a time. And the better the GPU, you know, the more powerful it is. So you can go with a higher bucket size. If you have multiple GPUs, so if you are working with multiple GPUs and you are lucky enough to have that, then you can actually be rendering multiple buckets at a time. But it will tell you, like, I believe if you're working on a high spec machine, it will say, hey, you can increase your bucket size to 256 or 512. And I think you also might get the opposite. If you don't have a lot of VRAM left, it will say you need to reduce your bucket size. And so this is where you could do that. Okay, right, let's get into AOVs, because unsurprisingly, we are drastically running out of time. So AOVs, what are AOVs? So AOV stands for Arbitrary Output Variables, and these are our multipasses. So if you're used to working with multipasses or render passes, this is just what they're called inside of Redshift. And what we can do is we can set up different passes for different elements like reflection, refraction, GI, and then Redshift can output these as their own AOV pass. And this can be really great if you're used to, like, working in post or compositing. It allows us to do these different adjustments, whether it's on our lights, whether it's on our like color grading or whatever, inside of post without having to re-render an entire frame out again. We have built-in AOVs, which are integrated AOVs. So these are our reflections and refractions and things like that. We also have light group AOVs, so we can have control per light in post. We also have things like depth passes, which are utility AOVs, and then we have the ability to also set up custom AOVs as well. And so let's take a look at how we can set these up really quickly. So in order to set up our AOVs, we just have to open up our AOV manager. And here we have all of our different AOVs. So if we're talking about basic compositing, so as you can see here, there are loads of different available AOVs, loads of different passes. And it's always going to be handy to have a little bit of knowledge about compositing, but by no means should this limit you from using AOVs. Like, I've not got a lot of experience in compositing, but this stuff can be learned. And so if we're talking about basic compositing AOVs, what we'd want to grab is diffuse lighting, GI. We'd then want our reflections, which are here. Let me just increase this so I can actually see everything. Okay, so refractions, you'd probably want refractions if you have refractive materials going on. As you can see, I don't, but I've accidentally pulled that in instead of reflections. We then have specular lighting. And so these would be like our basic AOVs that we'd want to set up for some basic compositing in whatever software you want to use. Like for me, it'd be After Effects. And so let's take a look. So we have our different options. We have our diffuse lighting, and then we have our multipass output enabled as default. So we have multipass checked. And so what this is going to do, this is going to create an OpenEXR file that contains all these multiple AOV layers. And this is really great. If you're rendering out like an animation, let's say like a 90 frame animation, you don't want to direct diffuse lighting, GI, refraction, reflection, and specular lighting for each of those frames. I mean, you might do, but if you don't, you want to have a multipass which gives us a layered OpenEXR. If you do want a direct file of each one, so if it's a still, for example, and you want to have a direct of each one, you can just hit that direct button, enable that, and then it's going to open up this direct output where you can choose your path, your data type, your format, whether you want it, you know, like full 32-bit, we can control that in there. And then we can also denoise these as well, you know, if we did want to.
So Elly, quick question.
Yeah.
If you enable, like, let's say your diffuse lighting pass right there, if you enable multipass and direct, is that going to make it so that the diffuse pass is in the multipass EXR and also has a separate EXR sequence? Okay, cool.
Yeah, you'd get your multi-part EXR file, which would have all your different AOVs in that are on that multipass, and then you'd also get like a separate direct path as well for however you set that up on there.
Okay. Oh, also with Cinema, if you don't do any, if you do make a multipass EXR in regular Cinema, if you don't say anything, if you just say like, oh, I'm just going to add a depth pass or something like that, it automatically renders out an RGBA beauty pass by default anyways. Is it this case here, like do you get a beauty with this too, with the RGBA, or do you have to specify that I want the alpha?
So you need to drop in your beauty AOV.
Okay. Okay.
And that's how you would get that one in there.
Okay. Thank you.
No worries. That's cool. So we can also really quickly, I know, you know, we're going to overrun. I think I've just accepted that now. What we can do, we can kick off our Redshift render view. And once we've, let's say we've set up some of our AOVs, we can even see what they look like by using our AOV dropdown. And so we can see what our different passes are going to be looking like before we even render those out. And so this is a useful tip to see, you know, how these are working. And as we can see, we've got AOVs for a bunch of different things. Like I've got a mission in this shot, so I'm going to throw in my mission, and I can see that as well, render out my mission pass. If we're working with volumetric lighting or fog, we can be controlling that as well and setting up a separate pass for that. And then we can, so we're talking about depth passes, we can control our depth pass and then our depth mode depending on how you work. And a cool one that I wanted to show like really quickly is it's like a cool way of like masking things out, and that's using like the puzzle mat. So if we drop in our puzzle mat here and we just take a look at what this looks like. So we have a mode, and I'm actually going to set this to object ID. And then what we can do, we can change our ID values and we can set these up on our different objects. And so let me just stop that for now. And what I'm going to do, I'm going to set up a different object ID for my different objects here. And we can use this as a way of masking things out. So how do we set up object IDs? So for a start, we need to go to grab a Redshift object tag on our particular object. Then we're going to go to object ID, override, and then we're just going to set a value. And then I'm just going to, let's set up 3 for the sake of it. So just copy and paste in this tag. And so we have object ID 1, 2, and 3. In my puzzle mat, I've set my mode to object ID, and I'm going to set this to 1, 2, and 3. And now what I'm going to do, kick this off, choose puzzle mat, and we need to go in bucket mode for this in order for us to see our different puzzle mat IDs. And then what we can see, we've now set up an individual ID and sort of like a mask for each object in our scene. And what we could do, we could actually add a second puzzle mat, and then we could have like 4, 5, and 6 and do the same thing in here. So you're not limited to just these 3. What else did I want to go through? Oh, okay, yeah. So one final thing, like I know we're kind of like speeding through AOVs, but I can always add some more like webinar sessions for AOVs because it's a pretty interesting topic to go through. Let me switch that off and switch that off. So we did talk a little bit about light groups. And so for that, what I'm going to do, I'm going to come back to my final scene. And we don't really need to see that rendering. Come back into my render settings, into my AOV, into my AOV manager. And so we can set up light groups with some of our AOVs. So only a few of them are compatible. So beauty, diffuse lighting, reflection, specular lighting, refraction, GI, subsurface scattering, and emission all work with light groups. And so what I'm going to do, let me grab my diffuse lighting. Inside of diffuse lighting, we have our light groups. And so I've actually already set up some light groups for this shot. And so we have different we've set up our different area lights and our different light groups. And then what we can do, we can then render out these different light groups as separate EXR passes. And then this basically gives us control to adjust these different lights in post. So if we come into After Effects, I've got my different passes here. So I've got my things. Let me just pull these in. And then, because they're way too big, then we can pull all of these into here. And then if we just pull this off, we have like our, effectively what would be our beauty pass. And then one of our light EXRs, which could be these neon tubes here. So that was one of the passes that we set up. And then if we just change this to, I don't know, like color dodge, and then drop exposure on it, and then like up our exposure. We could then add like a wiggle expression and animate this different light group or light pass on our animation. And so yeah, that's how you would set up light groups, or and why you would maybe set up light groups. And I know we've absolutely kind of like flown through that. But were there any questions on AOVs? Again, I will make sure I go through, you know, all these questions and do a Q&A, because I know we've kind of jam-packed this full of a lot of information, a lot of technical information as well.
One question: object buffers are the same as object IDs, right? That does the like similar things.
Sorry, say again.
Object buffers in Cinema are the equivalent of object IDs in Redshift.
Yeah.
Okay, just making sure.
Cool. Right. So let me come back to here. Let me put my camera back on, because we're pretty much at the end now. I know we sort of flew through a lot of that stuff. I'm very aware of that, but we got through the majority of what we wanted to get through, which was cool. And you know, again, it just means we can run more of these sessions. Like that's my excuse, really. That's my excuse really for doing it.
Yeah.
So let me get my lovely little presentation that I love to do. Right, so thanks to everyone for being here, and for everyone who's still with us. Like, I know we love to overrun. I know that was full of loads of information. I wanted to try and, you know, fit in as much stuff that we hadn't gone through yet, with advanced render settings, with our Kitbash textures, and, you know, post effects and AOVs and things like that. I wanted to try and fit as much as I can into 2 hours. It's surprising how quickly it goes. Like, I don't know about you, Chad, but I find
it blows by. It feels like 5 minutes.
Yeah, it really does. Maybe we'll do them longer next time. So further learning wise, because you know this is the end of this Redshift workshop. We've had a really great 4 weeks together, dove into a variety of different stuff, and you guys can catch up on all of those sessions on the Maxon Training Team YouTube channel. So head over to that, and we actually have a hands-on playlist, and all of these sessions are timestamped as well. So this one will be on there probably by tomorrow morning. And so you go back through, maybe like half speed, and go through some of this stuff again if you need to. And then as of starting this Monday, believe it or not, we're starting a new Demystifying Post-Production series, and it's all to do with Redshift. So we thought we would time it so it comes after this workshop, and so we can dive into potentially some more intermediate level topics. And so it's me, Lionel, and Dustin. And the plan is we're going to be going into rendering particles with Redshift, and that's going to be particles inside C4D as well as X particles. So we had a couple of questions about that over the last few weeks as well. So we're going to be looking at, X particles and Redshift quite a bit, as well as rendering volumes, again, C4D and X particles inside of Redshift. And then the wonder that is subsurface scattering is part 3. And then we're going to be diving into some like layering and stacking materials. So it's going to really be jumping on from what we did inside of node materials. And we're going to be creating some really beautiful looking textures in there as well. And if you're interested in learning rigging, so all you C4D users, if you're interested in learning rigging, next Wednesday is another new hands-on with Maxon series, and that's all to do with rigging with our wonderful trainer Joe Herman, and I'm going to be there as well. I'm going to be like the Chad for Joe. I'm taking on your role, Chad, so I'm like chatting with him, asking questions, answering questions, and so that's going to be a really great series, and it's 6 weeks as well, every Wednesday. So you'll be able to register for that soon as well. And like so much other stuff that we have going on. If you want to hang out with us, we run an Ask the Trainer every second and fourth Thursday, where we just basically hang out all together on YouTube Live, and we answer your questions on Cinema 4D, Redshift, Red Giant, and we ask and answer as much as we possibly can in those sessions. And so feel free to come and join us there. And then, as Chad, you already talked about, Max's colour show with Max on Colour, which I know you've been a part of. So you can vouch for how incredible of a show that is, which is relatively new. He only started it a couple of weeks ago. And so if you want to know all about like colour management and those incredible topics, then I would recommend that, definitely.
Awesome. Thanks.
And then finally, for anyone who doesn't know, when this session ends, you actually get given a survey for feedback. And then we love hearing from you guys. Genuinely, we read all of your feedback. We read all the survey stuff, read all of your comments. We really love to know how you guys feel about our sessions, what you like, what you don't like, what you want to see, future topics. Genuinely, everything we plan is normally because of the things that you guys have suggested. And so we definitely want to hear from you guys on anything to do with Redshift or Cinema 4D or anything. Yeah, so feel free to let us know, all that kind of stuff. Sorry, my headphones are slowly dying, so I'm just changing to my speakers. And yes, finally, to all you lovely people still here watching us live, and anyone who's on the YouTube as well, I just want to say thank you so much. Like, you guys, and you as well, Chad. Like, Chad, it would not have been the same without you here. Genuinely, I'm so grateful to have you here, just chatting with me, asking questions, like answering some of the questions in the chat. I just want to thank all of you. Like, you've made these like 4 weeks in this workshop has been so much fun because of all of you guys. Like, it's like, I've enjoyed it. I hope you all have as well. Like, Chad, I know, like, we talk at the end of every session, me and Chad are like, oh my god, like, that was so great.
It's been amazing, Ellie. You did such a great job. Like, one of the best training courses ever. Amazing stuff. Seriously, thank you.
Well, it's all thanks to you guys as well, and I'm so glad that it's been like a great series. And so, you know, some of you may know, some of you regulars know, we love to give away free t-shirts, and so I actually got a little sneak preview of next month's coupon code. So that is Redshift Raising. So feel free to head over to, if I can come out of here, that would be great. If you head over to the project file section, which I think Chad has already linked probably a few times, head over to the course guide, and I've added a little secret link. that we can't tell anyone about. If you come down, free t-shirt merch link, click that, enter a coupon code, grab yourselves any t-shirt. You know, we've got Maxon 1, we've got C4D ones, and we've even got a little Redshift one down here, which you might have seen me wearing a few times over the last few weeks. All you got to do is pay for shipping, which is like £3 or £4 or something like that, and then yeah, you can grab yourselves a t-shirt as a thank you for being, you know, for being so amazing on this workshop. And yeah, it's been a real pleasure being here, and I'm looking forward to all the next ones. Like, I'm sad it's over, but as you saw, we have so many other sessions going on. This isn't going to be the last time we see each other, so I'm not too sad about it. But yeah, thank you to everyone. Thank you to Chad again. Honestly,
my pleasure. I thank you. I know it's been fun. We'll do it again. We'll do it again.
Absolutely. This will not be the last time that you see me and Chad on a session. That is 100% for definite. Cool. Right. So I guess, sorry for overrunning. You know, we have to. Got to say our thanks. Got to say our goodbyes. And I wanted to fill all of this stuff in as much as I can. But if there's anything you still want to know, drop us messages on socials, YouTube comments, training@maxon.net. We love to hear from you. Do not think, oh, am I bothering them by sending an email? No, we love to hear from you. So please do send that email and let us know what you want to see. So it's been a pleasure, everyone. I hope you have a wonderful rest of your days, rest of your weeks, and we'll catch you on the next session.
Awesome. Take care, everybody.
Bye, everyone. Have a good one.
Thank you so much.